Hey guys, we're going to start on page 10, our first topic in this book, and we're writing repeating decimals as fractions. So we've got this baseball team and we have their win percentages over here. This win percentage right here is the one we're going to be looking at, and they're telling us that it really is 0.5 repeating, but in order to fit it on the paper, we round it at the thousandths place. So fractions can actually represent these quantities a little more accurately, so sometimes we want to use fractions instead of rounding. So what we do is we have to convert it. So this is just showing you that 0.5 repeating we know has to be somewhere in here, and then down here it's just saying how do we know that this can be written as a fraction. And what I do is I think of other fractions that I know. So 1/3 I know is 0.3 repeating, and since that repeats, I assume, or I would guess, that 0.5 repeating can also be written as a fraction. So here's what we do. We say x equals 0.5 repeating, and then since only one digit is being repeated, we multiply by that power of 10. So 10 to the first is 10, so we multiply both sides by 10. So this side becomes 10x, and this side becomes 5.5 repeating. So then what we do is we subtract x away. So we subtract x away from this side, and since x equaled 0.5 repeating, we also subtract it from this side. So what happens is this 10x minus x makes 9x, and then this 5.5 repeating minus the 0.5 repeating, the 0.5 repeating minus the 0.5 repeating kind of just cancels out. So we're left with 9x equals 5, then we divide by 9, and we get 5 over 9. So the Sluggers won 5/9 of their games. So then down below they say, well, let us try it. So we're saying that x equals 0.4 repeating. So again, we've got one number repeating, so we're going to multiply both sides by 10. And that's going to get us 10x equals, and then multiplying by 10 just moves the decimal point one spot. So we're going to have 4.4 repeating. Then we take our 10x minus x, and we take our 4.4 repeating minus the 0.4. Again, we're doing the same thing because x equals this 0.4 repeating. So we're subtracting the same thing on both sides, even though it doesn't look like it. So 10x minus x is 9x, and then 4.4 repeating. This repeating 4 cancels this repeating 4, and we're left with just 4. So then we just have to write that as a fraction. We divide by 9, and we get x equals 4 over 9. So this team won 4/9 of their games. All right, we're going to go to the next page, which is page 11. So on page 11, we have another repeating decimal, but this one has one that doesn't repeat on it. So what we do is we're going to, again, since only one digit's repeating, we're going to multiply by 10 to the first, which is just 10. And all that does is it moves the decimal over one spot. So then we'd get 10x equals 2.6 repeating. So then we subtract x away from both sides. So we do 10x minus x, which gets us 9x. And then we do 2.6 repeating minus 0.26 repeating. So what that's going to look like is it would be like 2.66, we'll do another one with all these repeating, minus the 0.26 repeating. So what you'll see here is this 6 repeating right here after this 2 is going to start canceling all those repeating 6s. Excuse me. So then we would just have 2.6 minus 0.2, which is 2.4. So then I would just divide by 9, like they do right here, and I would get 2.4 over 9. Now, the reason why we don't keep this is because we don't want a decimal in our answer. Okay, so we would have to multiply everything by 10 to get 24 over 90. Okay, so he could have put 24 over 90, or he could have put something like 8 over 30, like an equivalent fraction. Okay, so then let's go ahead and do the try it here. So we're going to convert this 0.63 repeating as a fraction. Okay, so we're going to say, we'll do it, maybe we'll do it like up over here. We'll say x equals 0.63 with the 3 repeating. All right, since only one number is repeating, I'm going to multiply by that power of 10, so 10 to the first is 10. So I'm going to multiply both sides by 10. So multiply by 10, multiply by 10. This side becomes 10x equals, and then multiplying by 10 just moves the decimal point once. So this side's going to become 6.3 with the 0.3 repeating. All right. And then all I have to do now is subtract away that original piece. So I'm going to subtract x from this side, and on this side I'm going to subtract away the 0.63 repeating. So what we're going to do is I'm going to show it this way just so it looks a little clearer. What happens is these 3 repeatings after this are going to cancel each other out. Okay? So then you just have 6.3 minus 0.6, which is 5.7. And then on this side you have 10 minus 1, which is 9x. So then we're just going to go ahead and divide both sides by 9. These cancel. I get x equals, and then I would say 5.7 over 9, but we don't want that. So what I'm going to do is, to move this decimal to the right one, I just multiply by 10. So if I multiply the top by 10, I would get 57 over, and 9 times 10 is 90. So then let's just check real quick, and let's make sure. So if I do 57 divided by 90, I should hopefully get 0.63 repeating. So we know that we are correct. All right? And then let's go to our last type of problem here. So we've got 2.09 repeating. So since there's 2 numbers repeating now, we're going to multiply by the second power of 10, which is actually 100. So we're going to end up with 100x equals 100 times this number. All right? And all that does is move the decimal place twice. So that's why this is 209.09 repeating. So then we just subtract our x away from the original, and you can see that this 0.09 repeating cancels this 0.09 repeating. So then we just have 209 minus 2, which is 207. Then we divide by 99, and we get 207 over 99. Or if we made it into a mixed number, it would be 2 and 1/11. All right. So then we're going to go ahead and we're going to try this last one. Why don't you guys try it, and then we'll be done there. All right. Thanks, guys.